Hi friends, now we are going to learn Floyd's algorithm, and Floyd's algorithm comes under dynamic programming technique. Okay, as I said you that programming is here planning, right? It's not name of C programming or Java programming. It is a programming is reference here is programming. And dynamic is means that we are going to change our current values again and again dynamically, right? And problem solutions of current problems is depends on the outcome of previous iterations. Now, what is Floyd algorithm? Floyd algorithm is also called it as a all pair shortest path, right? All pair shortest path. In greedy methods, we have discussed that Dijkstra algorithms. Dijkstra algorithm was all about to find single source shortest path. It means source was already defined, right? Source is A, and from A you are going to find out all the distance. So if there is a 5 cities, and if you are going to find out the distance from source, and source is say third city is a source, right? From third city you are going to find the distance third to 1, third to 2, third to 4, and third to 5, n minus 1 distance you are going to find out. But if you are going to deal with the Floyd algorithms, then we are going to find out the distance of between 5 cities or 5 vertex, 5 into 5, 25 different outcomes you are going to get. A to all the vertex, B to all the vertex, C to all the vertex, D to all the vertex, and E to all the vertex. Okay. Since we are talking about the distance, it means we are going to perform the task for the weighted matrix, right? And we have already discussed what is weighted matrix. When there is a certain cost, values, weight on edge of the graph, right? We have vertex, we have edges, and each and every edges must have some cost or weight or distance, right, or values, right? That is called it as a weight. So we are going to perform Floyd algorithms on weighted connected graph. Okay, we are going to perform the task on this. It means when you are going to convert this into the adjacency matrix, that matrix will be called it as a weighted adjacency matrix. So we will be not having that matrix will not have only 0, 1. 1 is true, 0 is false. No, here we will have the certain distance. If there is no path, it will be infinity, but source to source distance will be remain 0. So diagonal element will be remain 0. And we have already discussed these on previous chapters. So that is why we are going and discussing that main part of Floyd algorithms. What is the example here? And how are you going to discuss this Floyd algorithm? Say we are having example, say A, B, C, D. A to B, say here we have a 5. B to C, say it is 3. A to D, it is 10. Right. D to A is, say it is 4, and C to A is 3, right? And here we have A to B is, say it is 2. So this is a connected directed graph. And which kind of graph it is? Weighted graph. There are certain weight on their edge, right? Now if you are going to convert this, right, into the form of matrix, such a way that you can give that input to the program, then we are going to write A, B, C, D, A, B, C, D. What is A to A? A to A will be remain 0. A to B, there is a path and 5. A to C, we don't have direct path. Hence, A to C, we call it as a infinity. A to D, we don't have, you have a direct path and distance is 10. Remember that if there is no path, there is no direct path between the vertex, we will be writing here infinity. But in a program, we are supposed to give comparatively larger values to represent infinity, right? Because infinity you don't have keyword in your keyboards, right? There is no keys that is written as an infinity, right, in your computer keyboard. Hence, this infinity to be represented by larger values. So here all the inputs are maximum of 2 digits. If you are going to make 999, that is comparatively larger values. Similarly, B to A, we don't have direct distance, hence it is infinity. B to B, 0. B to C, is there direct distance? No. So it is infinity. B to D, it is 3. Remember that here B to B we have mentioned 0 because source to source, B to B, distance is 0. C to A, we have a 3. C to B, we have a 2. C to C, diagonal 0. And C to D, we don't have direct path. Similarly, D to A, we don't have direct path. D to B, we don't have direct path. D to C, we have a 4. And D to D will be 0. Now look, there are so many infinity 1, 2, 3, 4, 5, 6 where distance are not defined. But after applying Floyd algorithms, these all will be converted. If there is a alternative path, these all will be converted into some certain values. And some values, constant values, even it will decrease if there is some indirect path, right? And having some of the distance is lesser than the direct distance. In that case also it will decrease the values. Okay, so this is the input, and input is what? Equivalent of given graph. So it is called weighted agency matrix. Okay. Now, in similar way, we are going to perform the task, right? So we are going to say k is equal to 1, k will behave like a row and column. But here we are not going to find out the possible path. We are going to find out the minimum distance. Our tendency is to find out the minimum distance. So here logically we are going to write code similar but except one statement. K is equal to 1 to n, I is equal to 1 to n, j is equal to 1 to n do. So this part there is no difference if we compare with Floyd'S algorithm. But cost of ij is equal to mean of, because our tendency is to find out minimum values, right, lesser values. Comparatively, cost of ij, direct distance, ij, direct distance cost, and here we have cost of ik, intermediate distance. See, this is behaves as a column here, and same k behaves as a row in this arrays. Okay, so k is intermediate. In this particular case, what is k? K is intermediate vertex. So ik and kj, I to k and k to j. Hence, there is a path from I to j, right? So if there is a path from I to k and there is a path from k to j, hence there is a path from I to j. So this path you are going to find if there is no direct path. And what is the minimum values among first parameter and the second parameter? We are going to update, keep on you are going to update these values. But from where you are going to start the journey? We are going to start the journey from k is equal to 1. So in this case, if we take k is equal to 1, k is equal to 1, it means what? First row and first column we are going to select. Right? If you are going for the same values here, this is the, I am going to represent 1, 2, 3, 4, 1, 2, 3, 4. K is 1, I is 1, j is 1. If this values is there and input of a of ij is 0, right? A of ij is 0. This is 0. And this part ik, this is 1 and 1 is 0. This is here 1 and 1. It is also 0, right? And plus this is cost of 1 and 1 becomes 0, because I, j and k all three are 0 in this case. When k is 1, I is 1, j is 1. We are representing these values, hence no change. But when k is 1, I is 1, j is 2, means we are talking about this path. So already values is 5. Value is 5, right? This value is 5. If this value is 5, then we are going to find out indirect distance. Ik 1 1 1 1, because I is 1, k is 1, no change in I and k, so it is 0, plus cost of kj, k is 1, j is 2. So let us see that what is the value of 1 2. 1 2, it is 5 only. Okay, so 1 2 is 5, so it is remain 0 plus 5. So 5 and 5 minimum is okay 5 only, so there is no problem. So you are writing here 5, no change. Look, here is infinity, right? 1 3, j is 3, j is 3, I is 1, k is 1. In that case, let us see that ij, we are talking about 1 3 positions, and that value is infinity. If this value is infinity, we will go in the right hand side, right? Ik, both are 1, so it is 0, right? Cost of kj 1 3, 1 3 is infinity. So infinity plus 0 is infinity. So infinity comma infinity. So what values will be happen? Infinity comma infinity. Minimum is infinity, so no change. So here is infinity. Now let us see that 10. Because whatever the shaded part we have done, right? We are not going to make any changes, right? Because our formula will not allow you to perform the task on this. Similarly here, since this is on shaded part, we are not in a position to change even if you are applying the formula. But you can keep the values k is equal to 1. Now for this place, I is 2 now. I becomes 2 now, right? And j will start from again beginning. So we are not going to change. Here this is the 0 diagonal element and 0 is minimum elements here, right? So no change. Look at this position. This position is responsible from these values and these values. So infinity is original values, direct distance, and here is sum of distance infinity plus infinity is remain infinity. So we are not going to make any change in these iterations. Let us see the 3. Here 10 plus infinity. 10 plus infinity is infinity and actual input is 3. So 3 is lesser or infinity is lesser? Of course 3 is lesser, right? Similarly, next iteration, look, here is 3 constant values, here is 5. You will check this 3 plus 5. Here original value is 2. Original value is 2. So just I am rewriting it such a way that you can correlate better. A of ij, A of ij, A of ik, A of kj. So this is the formula, right? And we are going to find out of this what? Mean function. So basically here we are going to find out mean of it. See, in this position A of ij, original value is 2, right? So you are writing mean of original value is 2, comma A of ik. A of ik means same row, k column. What is k column is 3. So it is 3 plus kj, right? 2 and j is 2, right? So 1 2, right? So it is 5. 3 plus 5. So we see that 3 plus 5 is 8. And this is 2. 2 is lesser or 8 is lesser? Of course it is 2 is lesser. So it will be updated with 2. So this is updated with 2. Diagonal element is 0, no problem. Here, let us see that. All of you please focus. Let us see that. Here, for this input, this 10 is needed and this 3 is needed. And we can see that we are able to update the values. So we will try to update again with this formula. Right, and for these instances, here we can see that I is 3, right? K is 1 and j is, which column it is? This value is from fourth column. So let us see that I3 K1 J4. Here we are going to write mean of IK 3 1. What is 3? Sorry, IJ 3 4. 3 4. It is infinity. So first parameter is infinity. Let us see second parameter. IK, I is 3 and K is 1. 3 1. A of 3 1. A of 3 1. A of 3 1. What is the value? It is 3 plus. Here K is 1 and J is 4. So A of 1 4. A of 1 4. What is the value? 10. Let us see that. Here our mean of infinity plus 10 plus 3 is 13. Infinity is lesser or 13 is lesser? Of course 13 is lesser. So we are going to update this with 13. So all of you can observe this infinity is replaced by 13. Right? No. Since this infinity is there in the line, we are not able to change it. Right? This infinity is depends on one input infinity, other input is 5. Infinity is 5 is remain infinity, no change. This is 4, but if you make a diagonal elements rectangle, it is infinity plus infinity is remain infinity, but original value is 4. So 4 is lesser. This part will give you 4 and diagonal is 0. So this is after one iterations k is equal to 1, we got this outcomes where one of the infinity is replaced by 13, and if you see that how this 13 is 3 4. 3 4 means C to D. C to D you don't have direct path. Right? If you see that this place is from C to D. C to D we don't have direct distance, but there is a path C to A and A to D. C to A is 3 and A to D is 4. So 3 plus 10 becomes 13. C to A and A to D. 3 plus 10 is 13. So that values you got it here. Right? For next iterations, again you are going to select k is equal to 2 rows and column. So let us see that k is equal to 2. It means this will behave like row and column as well. And what outcomes you got? 0 5 infinity 10. 0 5 infinity 10, then infinity 0 infinity 3, infinity 0 infinity 3, and we have 3 2 0 13, 3 2 0 13, and last is infinity infinity 4 0. K is equal to 2, it means what? We are going to select second row and second column. Now this value is depends on this and this. Infinity plus 5 is very large value, so let it be 0, so no problem. Here this part we will check this infinity. 5 plus infinity is remain infinity, no change. So this 5, this is infinity. You will see here, friend, all of you please focus that this original value is 10. If you write again that formula, A of Ij is equal to mean of A of Ij, comma A of Ik plus A of Kj. If you see this formula and correlate with this input, k is 2, k is 2, and what is I for this position is I is 1, I is 1, and j is, see that 4, 1 4. So 1 4 original value was 10. So you are writing mean of 1 4 is 10, comma A of Ik A of 1, 2. What is the value of 1, 2? 1, 2 is 5. Kj. K means here 2 and J 4. 2, 4. 2, 4. Value is 3. 5 plus 3 is 8. So here we have mean 10, 8. Right? And among this you can see that which is minimum? 8 is minimum. So this input, even though it is constant values, we are going to replace by minimum values. Now it becomes 8. To see that, what is position of this? A to D. If you see in our original graph, A to D, direct distance was 10. But there is indirect distance A to B and B to D. A to B 5, B to D is 3. So 5 plus 3 is 8. And that is why Floyd's algorithm is giving you outcome as a 8 and you have updated it. Similarly, a values is there in this shaded part, we are not in a position to change because one of the values are self, so it will not change. But you can check here 3, this 3 is related to this and this. Infinity plus 2 is remain infinity, so no change. 2, no change, it is on the same shaded area. 0 is minimum. 13, all of you please see that this 13 is again related to this and this, 3 and 2. So actually this 13 is going to replace by 5. Let us see that. This 13 is a place of 3 to 4, means C to D path. C to D. C to D, there is a path is 3 plus 10. In original graph we kept infinity. This infinity is replaced by 13, right? This 3 plus 10. But there is another path which has lesser values called C to B and B to D. 2 plus 3 is 5. So, we had a value 3 plus 10, 13. Now we have 2 plus 3 is 5. So, now we are going to replace this 13 by 5. Alright. So, say for this position, what is values? What is values here now? Value is K is remains same, K is 2, but if you see that this is third row, fourth column, so I is 3, I is A of 3, 4, comma, A of 3, 2 plus A of 2, 4. If you see that, mean of this A of 3, 4. What is the original value of A of 3, 4 here is 13, comma A of 3, 2, 3, 2. What is the value? 2 plus A of 2, 4. 2, 4 is 3. Hence, we can find mean of 13, comma 2 plus 3 is 5. So, 5 is lesser, so it is going to update with 5. Similarly, now we are going to perform the task for this. Here we are not able to change anything because one input is, both the inputs are infinity, so it will remain infinity. Here this is shaded part infinity, this is a 4, infinity plus infinity is remain infinity, so 4 is lesser and diagonal element 0. So after k is equal to 2, this is our outcomes, right? And for next iterations, we are going to select k is equal to 3, right? K is equal to 3. You will select a k is equal to 3, third row and third column. Look, one of the input is infinity, it is not allow you to make any changes in this part. In this part also you are not able to make any changes because one of the inputs are infinity. So let us see in this part. About this position, this value is related to this and this. So 4 plus 3 is 7. This value will be 7. Similarly, this value will be 6. 2 plus 4 is 6. So let us see that what is the position here. It is D to A, we can get 7 and D to B will be getting 6. D to A, we don't have direct path, but there is a path D to C and C to A. 4 plus 3 is 7. Similarly, D to B, we don't have direct path, but we have a path for D to C and C to B. 4 plus 2 is 6. So hence, we can update that values, right, by 7 and 6. And that will be after updating k is equal to 3. After performing this k is equal to 3, our answer is going to be 0, 5, infinity 8. 0, 5, infinity 8. Infinity 0, infinity 3. Infinity 0, infinity 3. 3, 2, 0, 5. 3, 2, 0, 5. 7, 6. 7, 6, 4, 0. 4, 0. So we have done with k is equal to 3. Now we are going to perform k is equal to 4. Last iterations. 4th row and 4th column. You will see that this is 0, no problem. Here it is 5 and this is responsible for this 6 and 8. 8 plus 6 is 14. 5 is smaller, no problem. Here is infinity, but this infinity is related with this 4 and 8. 8 plus 4 is 12. Hence, this infinity is going to replace by 12. Similarly, 7 plus 3 is 10. This infinity is replaced by 10. Here 6 plus 3 is 9, but it is 0, no change. 4 plus 3 is 7. Here is infinity, so 7 is lesser. 7 is lesser and this is 3. Similarly, 7 plus 5 is 12, but it is 3, no change. 6 plus 5 is 11, but here is 2, no change. 4 plus 5 is 9, but here is 0, no change. And here is 5. And this is on line, shaded part, so no change. So this is our final result, right? And this is also called all pair shortest path. We can see that if you are going to write A, B, C, D, A, B, C, D. If we correlate this matrix with our original graph, we can find many changes, right? Many infinity was there, larger values was there, all are replaced, and we got finally lesser values and optimal values. Now hereafter there is no possibilities of decreasing the values. This is the minimum one. In these iterations we have updated we have updated B to A, we have updated A to C, and we have updated B to C. B to A and B to C. Let us see that B to A and B to C. B to A we don't have direct path, but there is a path, right? B to A called 5. B to A. Here is 3 plus 4, 7 plus 3, 10. So B to A there is a path, B to D, D to C and C to A. And that is why you are getting via two intermediate vertex, we are getting the final path. Look, B to A you are getting 10, that is via two intermediate path. Similarly, B to C, we have a path B to D and D to C. 3 plus 4 is 7. So we got that 7. Similarly, A to C, we got 12. Let us see that A to C. A to C, we don't have direct distance, but A to C there is a path, right? A to B is 5, 5 plus 3 is 8, 8 plus 4 is 12. Means via two intermediate vertex A to B, B to D and D to C. So this Floyd'S algorithm is capable of finding all possible path between the vertices, and we got this all. And all this happened because of these algorithms, as we have discussed in past. About summary, dynamic programming works on the principle of optimality and Floyd's algorithms to find all pair shortest path vertices between the vertices, or you can say the cities. It is used to map software like a Google or Apple Maps because it is related to the shortest distance. It make use of shortest distance algorithms. This is also important for the road network operations and logistic research because in that case there is a tendency of either you are going to find or you are going to complete the task in lesser amount of time or shortest distance you are going to cover, such that transportation cost will decrease or time will decrease. So hence this is important. Shortest path algorithms are also very important for the computer network like internet kind of, right? When you are doing cabling, right? This is very much useful, right? So Floyd algorithms can be used wherever you feel like that to find shortest distance between the vertices. Thank you.